Hey guys, what's up? Welcome back to another video. My apologies for not really making too many videos lately. I actually moved, if you couldn't tell. I'm in a new location. I know it's an empty wall right now, but hopefully in the future it'll be more interesting or something like that. But I wanted to get back into making some videos and stuff. I know that I've been working on that database project, and that's still going on. Still 100% doing that. What I ended up doing though was kind of taking a step back, really trying to learn more about how databases work myself before trying to actually build a database. I don't know why I didn't do that in the first place, but that aside, what we're going to do is start a new series called Databases Uncovered, and this is basically going to be everything that I can possibly learn about databases. I'm going to just kind of throw it out there and make some videos on it so that it'll, solidify in my mind and I'll be able to understand it a little bit better, and hopefully it'll help some of you guys out there, anyone who is interested in how databases work. Maybe you're building your own database, or maybe they fascinate you like they fascinate me, and you just want to learn more about it. I don't know, whatever. But so while this is going on, I'm still going to be working on the other series, which is building a database. So I'm still doing that kind of simultaneously. But it's important to understand how they work before trying to go and make one, right? You wouldn't. Same thing with like a website or really anything. You kind of need to, well, sort of the same thing. You need to understand some fundamental things before you can go and build whatever it is you're trying to build. And of course, you can learn things along the way. And so that's kind of the goal of this series and what I'm doing right now. So without getting too much into me talking too much, which happens a lot, let's just start talking about the series goals and what we're kind of going to be doing in these videos. So the first thing is that we want to understand how data is stored on a physical device. So that's one of our goals. The next thing is that we're going to identify and explore the components of a database. And we'll kind of do that at a high level in this video, and then we'll dig deeper into it in the next video, or in following videos. The next thing we want to do is understand the theory behind how databases work. And so there's a lot there, and it's a really, really fun part, I think, to unpack. We're also going to ask questions and add topics along the way. So I want to reserve the right. It's like one of those things where, sometimes you know what you don't know, and then sometimes you know that you don't know things, but you don't know what those things are. And so to some extent, that's kind of where I am right now, right? There's some things that I know that I don't know, and I know what those things are. And then there's other things, things that I don't know what those things are that I don't know. And so I want to reserve the right to ask questions and be able to add topics to this series. So I can't really say for sure that, this is going to be 1 out of 10 videos to learn about how databases work. I don't know. We might, a year from now, have 100 videos on this. I really have no idea. And to be honest, it's something that I'm really excited for. And I hope you guys are too. Okay, so now let's kind of jump into it, right? Let's get right into what we're talking about here. So let's talk about some database types. And before I go on to the next slide, I think what people think about when you hear about database types is, let's say, like relational versus non-relational, or SQL versus NoSQL, or unstructured versus structured, right? And that's true. Those are database types, right? But that's actually not what we're talking about here. That's like a higher level of abstraction away from where we're kind of thinking about here, right? What we're talking about here are online transaction processing, and then online analytical processing. Sometimes you'll hear OLTP, or just OLTP, because you can't actually say that phonetically. Or you'll hear OLAP or OLAP. And these are the two main types of databases that at the end of the day, your relational database or your NoSQL database, your unstructured database, whatever you want to call them, they all fit into these two categories here. And so let's start with the OLTP OLTP database. So this is generally for user-facing applications. And we have predefined queries, and they're short-lived queries. Okay, so let's think about that in terms of things that we do on a daily basis, right? So if you're just learning how to code right now, and you're figuring out what databases are and what they do and whatnot, chances are you're going to be working with an OLTP database. So for example, like Postgres, MongoDB, basically most of the databases that you've probably going to be working with. I think DynamoDB would fall into that category, although potentially it could fall into OLAP. So most of the databases that you're going to be working with, especially if you're building like an app, are going to be OLTP databases, right? And then the other side of it is OLAP, OLAP, and this is used for aggregations or analytics and data warehousing and long-running ad hoc queries. So if you think about OLTP, right, on the point of being predefined queries, we kind of know what we're querying for, like get this user so that we can show their data on a database or on an app, like on the website or on an app, like some kind of front end for a customer or a consumer or something like that, right? So these are kind of, databases that we work with more often. An OLAP database, you might have like, maybe we want to, so on the point of like use for aggregations, we might want to say, well, okay, what is the average age of all users on our platform? And so an OLAP database is going to be really useful for this, right? And we can, like, that's an ad hoc query as well. So we might have this question that we didn't exactly know we were going to ask it before, and so we didn't have a query previously defined like we did with the user data for the OLTP database, right? So we have this question, or your boss comes in and says, well, what's the average age? Or like, what was the average spend on the website, right? And so we could go in and just ad hoc kind of query this data from the database. And there's something I just want to know. I didn't visualize this, and I do apologize for that. I should have done this, but there's a really, really fundamental difference between these two databases. And that is, a lot of times you'll hear the term like a column store. We'll get to this point later on, but you might have like a column store or like a row-oriented storage, right? And so OLTP databases are also generally row-oriented, whereas OLAP databases, OLAP, generally column-oriented. And what that means is that it's actually, it comes down to the actual physical location and way of storing the data on our actual computer, right? So in the case of a OLAP database, typically a lot of times they're column oriented, which means that instead of storing all of our records, think of a record as a row in a SQL database, or maybe a document in a document database such as MongoDB or something like that. We in a transaction processing database, OLTP, we store the data of a given record together. So let's say if I'm a user on my website and I have my age, my name, my username, my email, so on, right? All of that information is stored physically in the same location together on the disk, on the hard drive, right? Or on the SSD. But in an OLAP database, or a column database, right? Typically they're column databases. It's a little bit different. We don't store the data by row or by document or by record, all the same thing. We store it by column, or basically we store it by property. So we'd store all of the ages together, and we'd store all of the names together. And so that way, when we go to actually read the data, when we go to seek it, it's called, right? Or search for it. Well, search is a little bit different, but when we go to seek for the data, we don't have to go and say, okay, got this, now go out and find that, or go out and find this next record, right? All of the data is stored in the same place, or not in the physical like memory address same place, because you can only have one thing there, but in the same location, generally speaking, right? And so that's a big thing to understand here, and I will try to, in the next video, maybe not in the next video, I'll try to at some point go into the differences about this. I think it'll come up when I go over like column versus row databases. I think it'll come up naturally there. That's probably why I didn't put it here, but that's generally the gist, okay? So let's talk about some database architecture. And this is going to be like a high-level overview of what actually goes into a database. Like, what is a database made up of, right? What are the components that we have that make a database tick, make it work, right? Okay, so a database is made up of, it looks like 4 layers, okay? And each of these layers might have different things in them, as you can see, but basically we've got 4 layers. And we're going to start, actually, I know that it might make sense to, it might be natural to start with this transport layer, but I'm actually going to start, oh no, you know what? I am going to start with the transport layer because all my animations go in that order, so never mind that. So we're going to start with the transport layer, right? And the transport layer is going to handle communication. It might host a server. It'll pass on queries to the query processor, and it'll also return the result back to whatever client is trying to access that information. So, for example, Um, when you interact with a database such as MongoDB or Postgres or whatever, you're typically kind of speaking to, I mean, you kind of speak to, like, let's say the server that the database spins up for you, right? And that's this second point here of host to server. But typically, what you're doing on a broader level is you're really interacting with the transport layer, not so much anything below that. I mean, your query might be acting with, interacting with things below that, but not you as the developer. All right, so let's talk about this query processor. So now, my understanding is that this is where a DSL would come into play. So let's say, like I said, you're interacting with the transport layer. So we would make our request to, let's say, the server that it spins up for us, or the web server, and we would send our query, perhaps in the body of such a server, right? So maybe it'd be like a post request or something. And then the query processor, this is where the DSL comes in, right? So this is where it would actually parse our DSL, right? So in the case of a SQL database, SQL is the DSL. In the case of MongoDB, it's not called SQL. I don't actually know if MongoDB calls their DSL something like I don't know if it's like its own language. I mean, it's very JavaScripty, but it's it's a DSL nevertheless. And so we would send our DSL there, right? It gets parsed, it gets validated, and the parser is also going to remove whatever unnecessary parts there might be. The next thing is that it's going to populate the semantic model. I believe that's the case. And this is kind of specific to, like, I guess, how you write DSLs. And we'll also cover DSLs to some extent in this, because DSLs are a huge part of databases, how people interact with the database, obviously. So, but that's way down the line. We'll get there. And then the other thing that it does is it actually creates an execution plan. And the execution plan is basically the steps that can be taken to get to the desired result that the query is asking for, right? And so there could be 10 different execution plans that are options, right? And if, like, the optimizer is going to have to pick the best one, right? So it creates the execution plan, but it's also picking the best execution plan that it'll use, right? And so the way that we measure, or the way that it's determined if it's an option to be an execution plan here, is that if it gets you to the same result, it can be an execution plan. It's a viable option. And then the optimizer is picking for the best one of those options. The next thing is the execution engine. And essentially all this is doing is executing the execution plan. So there's really not too much going on there. Well, I mean, there's a lot going on there, but it's not like it's, there's no like subpoints, I guess, there would be the way to think about it. Okay, so scheduled transactions. So let's talk about the storage engine. Okay, so the transaction manager is actually scheduling the transactions. And this is important because, a database isn't necessarily catering to one client at any given time. A database might be catering to, 10 or 10,000 different clients, different applications trying to access the data held within it at any given time. And so the scheduler, or the storage engine, has to have a manager to schedule these transactions. Similarly, it also needs a lock manager, which is going to lock the physical data when these transactions are happening. So they kind of work in tandem, right? And so this is important because let's say my record. So let's say that the document, or the row that contains the information for my user account on a website, right? If, let's say, you out there watching, if you were trying to access or look at my account and look at my profile, but I was trying to edit it at the same time, right? If you accessed it and then I edited it, or they were so like lined up, right? It might turn out that you've got stale information. And so what we want to do is that while I'm editing it, you shouldn't be able to access it. It should be locked, right? Or no. Rather, better example. So, because that's not really the end of the world. Let's say that I'm trying to edit it and you're trying, or let's like Google Docs, for example. Let's say that we're both trying to edit it. It doesn't really make much sense if we can edit the exact same data at the same time, because we might be able to both be changing that same data, in which case something is going to get messed up. It's going to be out of sync. So while I'm editing it, making that request to edit, it needs to be able to be locked, and then your edit needs to wait to take place, right? Does that make sense? So that's kind of how that works. It's pretty high level. I don't know if it's the best example, but we'll probably get, not probably, we'll definitely get more into it as time goes on. So don't worry about that one. So access methods. So this is actually the data access and organization. So for example, read this or, read that, whatever. And then it's also going to be how the data is organized. This is going to handle how the data gets organized on disk as well. The buffer manager is for caching data in memory. So a lot of times, even if the database that you're working with is like an on-disk database, right? Like for example, Postgres or something, or MongoDB. A lot of times they'll still cache certain parts of the data in memory if it's accessed a lot or something like that. Another example is a lot of graph databases. For example, like Neo4j is known to be high memory usage, and that's because even though it is, it's a durable database, meaning that the data is persisted on disk, and thus if the computer restarts or crashes, assuming that it was saved to disk, you can still access it. It's not like if it was in your main memory, it would be deleted, obviously, right? Because it gets reset. But that said, even though it's a durable, or even though durability is high there, right, it stores things on disk, it's still actually, to increase the speed of the database, it still actually uses a lot of RAM. And so what it does is it takes the active database or the active portion of the database, and it moves that, or it copies it into main memory, right? And so that's what this buffer manager kind of handles right there. And so that way it speeds things up a lot. And then the recovery manager, this is going to be what maintains the operation logs, so that if the computer or the machine that we're running on crashes, we can not recover everything necessarily, because there's a lot that goes into this, and we'll definitely get there. But we can recover some things that were recorded to the logs that handle this stuff. And I think that's going to be it for this video. I'm not exactly sure how long that was. 17 minutes. That was kind of a while, but 17 minutes. So I didn't want to go too much into this, because I know that this is like a really heavy topic and a lot to kind of address and absorb and consume. So that's going to be it for this first video. If you guys enjoyed this video, definitely please subscribe down below. I'm going to be coming out with obviously the 2 series now. The 2 series for sure, but there will be a lot of videos on Go and programming kind of coming up as I kind of learn more things having to do with this stuff. So I think it's going to be a lot of fun. If that's interesting to you, definitely subscribe, leave a comment, like. That all helps out the channel a lot, and I really appreciate it. So other than that, thanks for watching, and enjoy the rest of your day. Take care. Later.